Alright, hey everybody. This will be a demonstration of communication between Matlab and a Nios 2 soft processor through the serial ports. Alright, so I already have both of my environments set up and my code loaded. So I am using Matlab 2013, and I am using the Nios 2 IDE that's running on Eclipse. So just a little background, the board I am using is a Thoracic DE2i-150. I am using only the FPGA side of the board, so I'm not touching the Intel Atom side. So I have a Nios 2 embedded processor running on the Cyclone 4 FPGA. It's connected to my Windows 7 PC through a RS-232 to USB cable. I'm using the RS-232 port on the development board, and it's plugged into my computer's USB port. And then I'm just programming it through the Altera USB blaster. Alright, so the demo I'm going to do today is I'll be sending data, specifically a floating point number from the FPGA to Matlab, and I'll have Matlab display the information that that I gathered from the serial port. I will also have Matlab send serial data to the FPGA and have it blink LEDs in response. So the first demo I'm going to do is the LED demo. So this is having Matlab send data to the FPGA. So let me first explain the Matlab code. So for Matlab to access the serial data, you need to first create a serial object using the serial function. So pretty simple. You look up the COM port that your cable is connected to. You can do this in your device manager. So in my case, it's COM6. So you just do serial COM6. Then you can set the baud rate here if you want. You just do baud rate, and then I'm using 9600 as my baud rate. Once you create the object, you need to open the serial port. So you can use fopen to do that. Pretty simple. Now for this demonstration, I just have a really basic while loop. I just have a while one loop, and then I'm just gonna use the fwrite function to write to serial port S, and I'm gonna write a character to it. So in this case, I'm gonna write an A, a B, a C, and then a B and A. And I don't want this to go on forever, so I just limited it to 20. And once you've completed whatever you want to do with the serial port, you want to use fclose to close the serial port, and then delete it once you don't need to use it anymore. If you don't do this, you could run into problems later. You may have to restart Matlab or plug your USB into a different port. Now the Nios 2 C code is a little more complicated. I'm not going to go over how the QSys was set up or how the SOF file for the FPGA was set up and programmed. You can look that up online. I'm just going to go over how the C code works. So the first thing I'm going to talk about is the files that you have to include for this project to work. Since I am using the UART peripheral and the LEDs, you're going to have to include these two libraries so that you can talk with them. So the first one you include is Altera Avalon parallel input output regs.h. This file you can find under the under your project name _ board support package folder. So this folder is automatically created for you when you create the project. And just for quick reference, what you do is file new, and then you use the Nios 2 application and BSP from template. I use the Hello World template. So yeah, so under this folder, under drivers and include, you'll find the support libraries that you'll need to interface with your peripherals. Parallel input output is going to let you control the LEDs. And then the UART library will let you control the TX and RX data from your RS-232 port. For this demo, since I am inputting data, actually let me open up this file so you can see it. Since I'm inputting data to the FPGA, I want to use the receive commands. So in our case, this is the function we're going to use. It's input output read Altera Avalon UART RX data, and it takes a base as an input to the function. Now you can look this base up in system.h. These are all of the peripherals that you added to the QSys system. This file was automatically generated. Again, I'm not going to go over that, but in our QSys system, we have UART set up as UART base. We are using 9600 baud, 8 bits of data. I believe we don't have, there's no parity. Yep, no parity, and there's no hardware flow control. So back to our demo. So in my main function, I have a while one loop, and I just call the LED demo code. And all that does is it assigns the whatever it reads from the serial port, and I just assigns it to the character A. And then I just compare A with a bunch of letters. So if the A is equal to the letter A, then I will turn an LED on. Let me explain how we do that. So this function is part of this library, the Altera Avalon PIO raise library. And I use this function right here, IO write Altera Avalon PIO data, and this function takes a base and a data point. So if you look at systems, you'll see that we LED base is our base, and the data point. So it's a little hard to go over this without going through the Quartus and the Verilog stuff, but basically there's a register that corresponds to LEDs on the development board. So you assign the register to a name. In this case, we just used LED base. So then if I send the data 0x01, it'll set all the bits on that register to 0 except for the first one. And the first bit corresponds to the first LED, the second to the second LED, so on and so forth. So if it gets an A, turn on the first LED. If it gets a B, it'll turn on the second one, and if it gets a C, it'll turn on the third one. So since I'm setting it A, B, C, B, A, it'll basically flash the LEDs from 1, 2, 3, 2, 1, and then back and forth 20 times. Yeah, so let me just program this. Alright, and program the Matlab, and then run the Matlab script. I just call the demo. You can call it whatever you want. So if you run it, you'll see the LEDs on your board blink back and forth. At least the first 3 will. Alright, more stuff you can do with this is if you create a Matlab GUI, then you'll be able to like push a button on your GUI and then have your FPGA do something, whether it's to perform a different function or do something like or blink a different LED, whatever. And then the second demo I'm going to do now is I'm going to have the FPGA send a floating point number back to Matlab. And the purpose of this is so that you can graph the data in real time. I'm not going to graph it. I'm just going to show you that you can send data back to Matlab. So let me just change the code. Alright, so let me go over the Matlab code first. So same setup, but this time, since I'm reading data, I used fscan to grab the data. And for this demo, I'm just going to print it to the console here. So I use fprintf to print out what I read in using the fscanf. But since I'm sending back a floating point number, I want to use the format percentage sign f to show that this is a floating point value. And again, I'm just going to limit it to the while loop to run 10 times so it doesn't run forever. So now on the C side, the Nios 2 side, what I have is I have a send float function that I wrote. So let me explain that real fast. So basically, I've initialized a character array. I just set it to 20 digits since when we set up this code for the electrical engineering department DSP's capstone, we're assuming students don't need to use more than 20 digits. That might be different for you. Feel free to modify the code in any way. So to convert the floating point number and put it inside this array, we use snprintf. So basically, you use this function, you pass in the destination. In our case, it's this character array. We're limiting the conversion to the size of this array so we don't have an overflow in case the float is too big. And then we say it's a float type and the actual value. So then we just have a pretty basic while loop, and we just send the digits to the serial port one at a time. So then instead of the RX we had in this one, we just have TX, and we have write instead of read. So after you send one digit, you want to add in a little delay. I have a very basic delay function here, but it's just because the FPGA runs so fast that the communication will get messed up unless you put in some delay in there. And then once you've sent all of your digits, you want to send the termination character. So fscanf will only print out the data once it's seen the termination character. So if you don't see this termination character, it'll just buffer it indefinitely, which is not good. So I just send the termination character, have a delay again. So let me run this. Alright, what happened? Let's see. Okay, I guess I must have hit debugging by mistake, but it should be running now. Now in Matlab, if I run this, it should print out the number 12.56. Alright, there we go. So you'll notice that it didn't print out 10 values, and this is just because this while one loop is not running at the same time as the actual Nios, the FPGA side. So this was just so that it would run 10 while loops worth of stuff. But actually, if you take out the fprintf and you just run this as fscanf, you'll notice that it does grab 10 data points, but the data isn't being sent at the same rate. So you'll get these null values, but that's beside the point. So this if you this would be what you would do if you want to get real-time data from the FPGA and graph it in real time in Matlab. I'm not going to show you how to do that. You can go on the web and search for those. Actually, if you go onto the MathWorks website, they have a ton of these that you can just download, and it'll plot data through the serial ports in real time. So yeah, I'll let you look through those. But I hope that was a helpful demonstration. This was geared primarily towards the students in University of Washington Electrical Engineering Department who are taking the DSP capstone. So if you're one of those students, you should have been given all of the library files that let you do this, so you don't have to worry about the back-end stuff. But if not, you can pause the video and just copy down the code. And yeah, I hope that was helpful.